Hi everyone, I'm Allie, and today I will be presenting the Next Generation Science Standard 4-ESS2-1. So this is a fourth grade Earth Science standard. So this standard states that students will be able to make observations and or measurements to provide evidence of the effects of weathering or the rate of erosion by water, ice, wind, or vegetation. So here is the standard, all lined out from the website. I'll sit for a second if you want to look over it. It is on the website and you can always pause the video here, but I kind of get into how I utilize this and really constructed what I think a good lesson and activity would be around this. And I go into detail in that, which I will do now. So the timeline of my lesson. So this is kind of just like my general, what I think would happen for this to go smoothly is hopefully going into it, students would have a prior knowledge of observations and experimenting. This wouldn't be like an introductory unit to that concept as well. Like hopefully they would already know scientific method and things like that, and like lab safety rules, and to not like throw things or how to responsibly use materials. Hopefully they would already have like that prior knowledge, as well as like a basic introduction to writing and kind of recording findings. I'm hoping by fourth grade, they've already covered some of that in their previous science instruction, if not earlier in the school year. So kind of going into that with the assumption that they already know those things. So I would start by introducing the topic by asking the students if they had ever heard like the song or the saying, "Step on a crack and you break your mother's back," because it's kind of silly and like a fun way to like get students' attention. And it really is the first thing that introduces an effect of weathering and erosion in a way that is accessible and like very real in students' world. So after hopefully people are like hee hee and they giggle and stuff, then I would go into presenting the topic of weathering and erosion. So I want to introduce kind of like through conversation. So like, has anyone heard of weathering or erosion? Weathering, that kind of sounds like weather. Well, weather is when it rains or it snows or it's a sunny day out. Is that the same thing? No, this is more the effects of that weather, and really kind of getting the conversation rolling, seeing if anybody has prior knowledge. Maybe that's a good moment for like a KWL chart, kind of something like that, but giving just the initial presentation. Then I have an attention getting video that I think would be really cool that I have that I'll show in a second here. But showing weathering and erosion in action, because you can talk about it all day, but really seeing its actual impact on Earth is what will make students understand that this is such an important concept to learn, and that it is something that happens in the world around them. And you want it to be inquiry-based science learning, and I think that a lot of questions will come up from showing actual footage of that. So then I would have some vocabulary words and have students take some basic notes so that they can refer back to those things in the future, that they can use it during the experimentation point. And through those notes, rather than just giving vocab words, I want that to be discussion based with it, but I also want to give real world examples, because no one wants to learn something that doesn't feel like it applies to real life in any sort of way. And giving those real world examples, both like in the larger concepts and in things like cracks on the sidewalk, will be a good way for students to understand the world around them, which is ultimately a really important goal of science. Then I'll introduce the experiments and have students make predictions, which ties into that, like making observations and measurements. So they're making those predictions to observe and to write about. Then breaking students into groups to do the lab that they would follow along with the teacher, and then regathering and recording the findings and observations. So like making those observations about weathering and erosion so that it all ties back into this standard, nicely tied with a little bow. So I'll show just a second of this video. So this is my attention getter that I think is really neat. It's a time lapse of bluff erosion on Barter Island, Alaska. So it was a video that was taken over an entire summer. And it just, you can see how this area is really affected by weathering and erosion. I'm just gonna show like the very last end bit, because I'll post this with my video presentation that I'm doing. If you wanna watch it later, it's only like a minute. But it's really quite interesting to look at. So I'm just going to show like the last couple seconds of it, but you can see how the water is affecting things. The students would be able to see that originally it started off like a lot taller. It eventually falls off due to the erosion of it actually going away. But there's like really cool moments throughout it that like really show how weathering and erosion happens. And you can see how the different elements, like some days it's sunny, some days this water is really pulling up a lot of sand. Like look how tall it is here at the beginning. And then by the end, it looks a little bit different. And so that's a really cool way to show like weathering is happening, erosion is happening, and kind of give some real world context. Okay, so the important vocabulary that I would introduce is obviously the terms weathering and erosion. So weathering is the process by which Earth's surface is broken down into smaller pieces. Erosion is the process of moving things from one place to another. And deposition, that's one I haven't mentioned yet, that is to deposit things elsewhere. So that's where the things that have been broken up in the process of weathering and erosion, where they kind of go. So it's really important for students to understand that like you cannot have one of these without the other. You can't have erosion without the initial weathering. You can't have weathering without erosion occurring, and deposition. And it's really important for students to understand how those all connect. So giving those initial vocabulary definitions, but then expanding on that and really giving examples of like how that weather in that little video that I just showed clips for, like when the rain is coming down or the tides are like increasing, like you can see that erosion is happening because the erosion is like getting those rocks that are breaking down and that like mound, it's bringing them back into the water. That's the erosion. It's depositing the rocks into the water. So that's deposition. So they all really go all together. So super important to chit chat about. So then I would tie in some real world examples. So I have two that they're more familiar with, and then two that maybe are like bigger thinking things. So like sand on the beach, a lot of students either have been to a beach or they've seen pictures of the beach. So sand is created when the rocks in the ocean and in the water are broken down, that eventually creates sand. So that's something that's happened obviously over a very long period of time. That wasn't an overnight process, but like that's where the sand comes from, and it continues being weathered and eroded and back into the water. And beaches look different all the time, especially after like natural disasters. That's a really good example that students might be familiar with. The Grand Canyon is a result of weathering. So it's from the Colorado River, like going through it. It like formed these boulders and like broke things down, and you can see all the different levels in there. That is an example of weathering and erosion. These mushroom rocks I think are super neat to look at. So this is in a desert and like on a beachy area where wind has picked up the sand at a lower level. And so you can see at the bottom of these rocks where the sand and weathering has taken place, they've gotten a lot smaller and smoother. Whereas the top where the wind isn't really affecting or moving the rocks that come out of that sand and hitting it, that still looks just totally like an untouched rock. So it's really interesting to see how all of that wind that's picking up the little broken down pieces of rock is impacting this bigger thing. And then tying back to our initial example of step on a crack, you break your mom's back. Cracks in the sidewalk are a really great example of weathering and erosion that students have probably seen outside of their own school, like in the sidewalks in their neighborhood. Because when water gets into the cracks in the sidewalk and it freezes, or it really like just gets down in there, when it freezes, it expands, which causes cracks. And then also just like the process of erosion of like the rocks coming down and grinding on top of it also breaks it up. And that could even be another example would be like a pothole in the street. And you could talk to students about how in the winter, maybe they've noticed that their parents talk about, oh, I'm so frustrated, there's so many potholes right now, because the ice is expanding, the water is turning to ice and expanding, and the salts are also grinding up on the pavement, and it causes weathering and erosion. So the activity that I would do for the standard is kind of pictured here, and I'll get into more depth. I was really inspired from two different websites that I've linked their video examples here. I kind of combined them. It's like Generation Science and then The Good and the Beautiful Science. But they had a really great interactive example that I think is awesome for inquiry-based learning, and I'm going to talk about it now. So the materials that you need are listed here, and the details of the activity are listed here, and I also have them outlined in the supplemental document I've created. So I'm just going to kind of talk through how it works. So basically, you would take a cookie sheet that you could just get at the dollar store. I like to think this is pretty affordable materials too, which is good because schools don't always have huge budgets, but you would take a cookie sheet and you would put a book on one end to prop it up and slightly slope it, and then a towel at the other end to catch any of the extra runoff and things like that. But students would take damp sand and they kind of pack it onto that top part. So you can see it's on the top here. And using that sand, they can make different mounds and kind of valleys and little hills and things like that, different levels. And then students would take their finger and they would kind of trace a little river line down. So you can see that right here. And then they would line the river with little rocks and pebbles and things like that. And then something that I combined from the other is they would add 2 ice cubes to either end of the cookie sheet at the top, and making sure that the sand only covers the top sloped upward part of it. And then students would get to use different symbols basically and manipulatives to create the effects of weathering and erosion. So they would use a water bottle full of water to pour down the river. Oh my gosh, look how much of the sand and the rocks are starting to move out of where it was. That's an example of erosion, and deposition is happening here. That's where it's all being deposited, is at the other end. Using a watering can to simulate rain, and how does rainfall work? How does it work when it's coming from above and it's beating down over and over again? What if you pour it really hard at one angle, or what if you do it kind of a lighter stream? Playing same with the water bottle, like what if you're letting just a little bit go in, or what if it's a lot at once because maybe it's rain and there's excess water? Then using a straw, blowing to emulate wind through the straw so that students could see how that impacts. That picks up a ton of rock and debris and things like that. And also, like how we saw with the mushroom rocks, like changes the structural shape of like natural rocks and different landforms and things like that. And then the last thing is the ice cubes that would be on either side. You would periodically check and see when they're melting. Okay, are they kind of shifting downward and bringing sand with them? Is the sand clinging to it? Is it making like little dips in the sand where it's almost creating a new water source? And that is a really good way to look at like glaciers and how glacial weathering can impact the environment and kind of the world around us. And so I think that this activity experiment is a great way to get students hands-on working. While yes, it would be kind of demoed at the beginning, maybe by a teacher, the initial setup of how to get your project set up, the students are the ones controlling how much water is going where. They're the ones recording what the different elements look like and how that impacts. And they're really creating those observations and testing their hypotheses of, I think that rain is the most damaging, or I think that when you use water down the stream, it's the most damaging. And so it's really like exploration based, which is awesome. Which brings me into the last slide of my presentation, which just talks about how does this standard and this particular lesson that I'm sharing with you connect to that 6E model that we really thrive for. So with engagement, I like to think that this is a pretty engaging lesson. It lets students be hands-on, really like kind of get in there and get dirty with the sand and with the different elements and things like that. And there's also a lot of conversation within, like a conversation opportunity within this lesson, which is really good because it gets students thinking and making connections to the real world, things like that. Then exploration, again, through the activity experiment. Students are getting to not only write hypotheses before and kind of make predictions and things like that, but then they're actually getting to test them and explore like, wow, what does this look like? And they're getting to see a video of a real life like weathering and erosion taking place in real time. And that's exploring kind of further and through different examples and things like that. Explanation really falls a lot on the teacher. So that's the teacher introducing new vocabulary and tying in those real world examples. But most importantly, teaching in such a way that students understand it, can claim that information as they experiment, really get that deeper understanding, so then they can name it, they can share it, they can write about it and explain it to somebody else. They could be the teachers by the end of this lesson. Then elaboration, that goes hand in hand with this explanation. So students should be able to, at the end, write down those observations and those measurements that they've made. And like I said, teach it to someone new. Go home and teach it to mom and dad, or like their siblings or whoever they live with. You want students to feel confident in being able to talk about it and make connections to the real world. The evaluation aspect, this lesson lends really well to informal assessment. So the teacher can be walking around, asking students questions as they're playing with the different weathering elements, like, what do you notice when you blow through the straw? Like, how does the wind impact it? Do you think that's more than the river, like with the water bottle? Or were you surprised by anything? Like, really getting the students talking about it and elaborating on their thoughts, like things like, what did you predict would happen? Things like that. And then also, hopefully, at the end of the lesson, in that reflecting period that I have listed, where did it go? In the regathering and recording our findings, you can look at that science notebook afterwards and really see, like, okay, does the student understand? Do they seem to grasp the concept? It's a good check-in point. And then with e-learning, I think that while obviously this lesson is ideal to be in person because you want kids to be able to really like inquiry-based learn, like take ownership of figuring out what the weathering effects, like how they work. But there are really great videos that show this experiment that are kids doing them. So the kids might feel more engaged and they're really fun. And I also included in my supplemental document a crash course video for kids that's like engaging and has someone highly energetic talking about this subject. And I think that this lends really well. Like, there's a lot of really cool online videos of erosion happening in addition to the one that I already showed. And so I think for people who are still experiencing like pandemic learning, there are a lot of ways to make it applicable and still engaging. At least I hope so. It's never as fun when you're online, but there's definitely potential to make this a beneficial lesson online and off. But yeah, that is really my breakdown of standard for ESS 2-1. I hope it was helpful and I hope that you got something out of it. So thanks.